Dear friends, welcome back to my YouTube channel Journey with Vijay Kumar Shrivastav. Today we are going to study the topic precision farming. My channel is aiming to students who are preparing for various agriculture and general competitive examinations. Myself is in job and associated with agriculture seed industry since 20 years and I am placed in South. In extra hours, I am preparing these videos to provide content for students to support up to the best level. So let's proceed. What is precision farming? Precision farming or precision agriculture refers to the precise application of agricultural inputs with respect to soil, weather, and crop need in order to improve productivity, quality, and profitability in agriculture. Precision farming involves modern technology link remote sensing, global positioning system (GPS), GIS, geographical information system to improve productivity and profitability. Precision farming promotes efficient use of inputs like pesticides, fertilizers, irrigation water, and tillage whatever required. Precision farming promotes sustainable agriculture development. Precision farming is an approach where inputs are utilized in precise amounts to get increased average yields compared to traditional cultivation techniques. Precision farming is a concept of using the new technologies and collected field information, doing the right things in the right place at the right time. The collected information is used for data analytics, more precisely used for the better application, and it will help to follow best practices and eliminate unwanted practices. Precision farming is also known as precision agriculture, satellite farming, or site-specific crop management, and the popular definition is given as a technology-enabled approach to farming management that observes, measures, and analyzes the need of individual fields and crops. According to me, I can say the development of precision agriculture is shaped by two trends. First one, big data collection and advanced analytics capabilities. And second, robotics, which involves aerial imagery, sensors, sophisticated local weather forecasts. Adoption of precision farming reduces the production cost and wastage by adopting analytical software and technical equipments. In precision farming, there are rigorous data collection like soil testing, plot measurement, weather pattern analysis, and crop analysis through sensor-equipped devices placed along with the fields. The collected data is calibrated to devise conclusions, and based upon those results, a very detailed and precise sets of practices can be adopted for the increasing the productivity, increasing yields, and minimizing the costs. Now to study the goals of precision farming. It is having three goals. First one is profitability, second is efficiency, and third sustainability. As a profitability is concerned, it is working on return on investment to develop a methodology for identifying the causes within field variations in crop performance. Second is improving efficiency, where we are using resource efficiently and smartly to develop practical guidelines which are required to implement precision farming methodology to achieve best management. Third is sustainability, which is focusing on best socio-economic and environmental operations which assures additive improvements for all the performance indicators. It explores the possibilities of using remote sensing, global information system for real-time data management during crop growth period. Benefits of precision farming. Benefits in several ways can be traced in a single farm, and precision farming benefits farmers in several ways about which we will discuss here. Like first one is refined set of cultivation practices and choice of crops based on suitability of land. It will enhance agriculture productivity and prevent soil degradation in cultivable land, resulting in sustained agricultural development. Second is elimination of volatility and risks. GPS allows agricultural fields to be surveyed with ease. Moreover, the yield and soil characteristics can be mapped. Non-uniform fields can be subdivided into smaller plots based on their unique requirements. Third benefit is waste management. Precision farming provides opportunities for better resource management and hence reduce wastage of resources. Fourth is reduction in production cost. Dissemination of information about agricultural practices to improve quality, quantity, and reduced cost of production in agriculture crops. Refinement and wider application of precision agriculture technologies in India can help in reducing production cost, increasing productivity, and better utilization of natural resources. Fifth is minimum environmental impacts. Precision farming will minimize the risks to the environment, particularly with respect to the nitrate leaching and groundwater contamination by means of the optimization of agrochemical products. Sixth is optimized use of fertilizers and chemicals. It will reduce excessive chemical usage in crop production. Seventh benefit is water management. Water resources will be utilized efficiently under the precision farming. It can increase the efficiency of irrigation when water resources are low. Eighth is revolutionize modern farm management. It has the ability to revolutionize modern farm management in India through improvement in profitability, productivity, sustainability, crop quality, environmental protection, on farm quality of life, food safety, and rural economic development. It has the essential role in the monitoring of greenhouse conditions in agriculture fields. Here to study the strategies which are focused in precision farming. It can be defined as balanced real-time application of inputs which will reduce fertilizer, chemical and seed cost. The strategies are to increase in productivity and quality, improved economic analysis based on computerized captured data and field records, tracing of the production processes for further improvements, strategies to guarantee of food security and safety by improving food supply. There will be documentation process of profitable production processes, suitable approach as per environmental regulations, strategies to reduce or skip overlapping input application in a standard process and increasing working hours and high labor productivity. Focus on accuracy at higher speed and less impact or less affected by weather conditions. Precision farming cycle. The precision farming cycle or precision agriculture cycle consists of three stages: data collection, interpretation, and application. Under data collection, there is measurement of within field, especially variable soil and crop parameters, and monitoring of local weather conditions. And second, mapping of within field soil and crop parameters. Under interpretation, there is mapping of especially variable rate crop input applications, and under applications, especially variable rate crop input applications. In order to implement precision agriculture, different various instruments are needed. A satellite positioning system for sensing the position to which any measured field parameter must be geo-referenced, and then also the position where any crop input rate must be applied. There will be use of sensors for measuring the soil and crop parameters of a field, and devices for setting up and controlling the especially variable rate crop input applications. Needed of software for producing the maps of within field soil and crop parameters and those of especially variable rate crop input applications, and also for interpreting the measured data. Soil crop simulation models needed for identifying the cause of within field especially variability in order to adjust the crop input rates from the next growing season. Prospectus of precision farming in Indian agriculture situation. Precision farming aims to optimize field level management with regards to agronomic perspectives, technical perspectives, environmental perspectives, and economical perspectives. As agronomic perspective is concerned, there will be matching with farming practices and more closely to crop needs. There may be modifications and adjustment of cultural practices as per real need of the crop. In case of technical perspectives, best time management by using technologies as GPS, VRT, SSM, and financing. Under environmental practices, environmental perspectives, there will be sustainable development focus, reducing agriculture impacts by means of reducing input losses and increasing water and nutrient use efficiency. As economical perspective is concerned, the focus will be increasing efficiency, increasing output, reducing input, and minimizing the cost and cash flow risk and changes in revenue. Precision farming also provide farmers lot of informations which are needed to increase the productivity and profitability, and it is consist of build of a record of their own farm which will be analyzed and used for future reference, improving decision making, foster greater traceability, enhance marketing of farm products, improving lease arrangements and relationship with landlords, and enhance the inherent quality of farm products. So precision farming is helping farmers in a different several ways. Precision agronomics. In precision farming, precision agronomics refers to the combining of methodology with technology, and it's about providing more accurate farming technology for crop cultivation, and it involves various elements about which we will discuss here. First one is variable rate technology, VRT. Variable rate technology refers to any technology that enables the variable application of inputs and allows farmers to control the amount of inputs they apply in a specific location. The basic components of this technology includes a computer, a software, a controller, and a differential global positioning system. There are three basic approaches which are used in variable rate technology, which are map-based, sensor-based, and manual. Second element is GPS soil sampling, which is used for the measurement of available nutrient level, pH level, and range of other data. Data analysis will be used for input variable rate application for optimizing seeding and fertilizer applications. Third element of precision agronomics is computer-based applications, which are used to create precise farm plans, field maps, crop scouting, and yield maps. There will be precise application of pesticides, herbicides, fertilizers, which are helping to reduce expenses, produce higher yields, and create environmental friendly relations. There are some challenges also, like variable data and interpretation of applications. Next application is remote sensing tools, which are used in agriculture since 1960, and these are the important tools for monitoring and managing land, water, and other resources. The data enriches decision making on the farm and can come from several sources like drones and satellites. Now, artificial intelligence in agriculture. Artificial intelligence is the branch of computer sciences that emphasizes the development of intelligence machines thinking and working like humans. Like example, speech recognition, problem solving, learning, and planning. Artificial intelligence is expanding its footprints at the ground level, making a significant impact in world's most vital sector, agriculture. After healthcare, automotive, manufacturing, and finance sector, now artificial intelligence in agriculture is providing cutting-edge technology for harvesting with better productivity and crop yields. The agriculture sector is the foundation of the world economy, and with the increasing population, The world will need to produce 50% more food by 2050, for which artificial intelligence and precision farming is very, very important. Artificial intelligence enabled technologies can help farmers to get more from the land while using resources more sustainably and smartly. As artificial intelligence in agriculture is concerned, emerging technologies has enhanced crop production and improved real-time monitoring, harvesting, processing and marketing. The agriculture robots and drones are making tremendous contributions. Various high-tech computer-based systems are very, very important in weed detection, yield detection, crop quality, automated irrigation systems, weeding and spraying processes. Automated sensing technologies like GPS modules, robots using Google Maps, use of drones, yield mapping, and field monitoring systems are playing very, very vital role in improving the agriculture production. Now to study the tools and equipment used in precision farming. Precision farming is a combination of application of different technologies. All these combinations are mutually interrelated and responsible for the development. There are various tools about which we will discuss here, like first one is Global Positioning System, GPS. GPS allows precise mapping of the farms and together with appropriate software inform the farmer about the status of his crop and which part of the farm requires what inputs such as water or fertilizer or pesticides applications. Second is Geographic Information System, GIS. It is software that imports, exports and processes spatially and temporally geographical distribution data. Third is grid sampling. It is a method of breaking a field into grid of about 0.5 to 5 hectares area. Sampling soil within the grid is useful to determine the appropriate rate of application of fertilizers. Fourth is variable rate technology, VRT. The existing field machinery with added electronic control unit ECU and on-board GPS can fulfill the variable requirement of inputs. Spray booms, the spinning disc applicator with ECU and GPS have been used effectively for patch spraying. During the creation of nutrient requirement map for VRT technology, profit maximizing fertilizer rate should be considered more rather than yield maximizing fertilizer rate. Next tool is yield maps. Yield maps are produced by processing data from adapted combine harvester that is equipped with a GPS. Integrated with a yield recording system. Yield mapping involves the recording of the grain flow through the combine harvester while recording the actual location in the field at the same time. Next tool is remote sensors. These are generally categories of aerial or satellite sensor. They can indicate variations in the colors of the field that corresponds to changes in soil type, crop development, field boundaries, roads and water, etc. Aerial and satellite imagery can be processed to provide vegetable indices which reflect the health of the plant. Other tool is proximate sensors. These sensors can be used to measure soil parameters such as nitrogen status in the soil pH, and crop properties as the sensor attached tractor passes over the field. Computer hardware and software. In order to analyze the data collected by other precision agriculture technology components and to make it available is usable formats such as maps, graphs, charts or reports. Computer support is essential along with the specific software support. Other tool is precision irrigation systems. Recent developments are being released for commercial use in sprinkler irrigation by controlling the irrigation machine's motion with GPS-based controller. Wireless communication and sensor technologies are being developed to monitor soil and ambient conditions along with operation parameters of the irrigation machines where we can measure the flow and pressure to achieve higher water use efficiency. Next tool is controlled traffic farming. The use of precision agriculture techniques on arable land is the most widely used and most advanced amongst farmers. The controlled traffic farming (CTF) is a whole farm approach that aims at avoiding unnecessary crop damage and soil compaction by heavy machinery, reducing cost imposed by standard methods. Controlled traffic method involves confining all field vehicles to the minimal area of permanent traffic lanes with the aid of decision support systems. Another important application of precision agriculture in arable land is to optimize the use of fertilizers, especially nitrogen, phosphorus, and potassium. Next tool is rate controllers. Rate controllers are devices designed to control the delivery rate of chemical inputs such as fertilizers and pesticides, either liquid or granular form. These rate controllers monitor the speed of the tractor or a sprayer traveling across the field, as well as the flow rate and pressure of liquid, and making delivery adjustment in real time to apply a target rate. Rate controllers have been available for some time and are frequently used as stand-alone systems. Now, yield monitor. Yield monitors are a combination of several components. They typically include several different sensors and other components, which includes a data storage device, user interface, and a task computer located in the combine cab, which controls the integration and interaction of these components. The sensors measure the mass or volume of the grain flow, separator seed, ground speed, and grain. In the case of grains, yield is continuously recorded by measuring the force of the grain flow as it impacts a sensible plate in the clean grain elevator of the combine machine. Precision livestock farming is one of the important components of precision agriculture, precision farming. Precision livestock farming is defined as the management of livestock production using the principles and technology from precision agriculture and processes suitable for the precision livestock farming approach includes animal growth, milk and egg production, detection and monitoring of diseases, and other aspects related to animal behavior, physical environment. System includes milk monitoring to check fat and microbial levels, potential infections, and a new system for data monitoring for feed and water consumption, and acoustic sensor for health monitoring of animals. Now to study about emerging technologies. Precision agriculture is an application of breakthrough digital farming technologies. First one is robots. Self-steering tractors have existed for some times now. A John Deere equipment works like a plane on autopilot. Technology is advancing towards driverless machinery programmed by GPS to spread fertilizers or plow land. Agriculture robots, also known as agbots, already exist, but advanced harvesting robots are being developed to identify ripe fruits, adjust to their shape and size, and carefully pluck them from branches. Next is drones and satellite imagery. Drones and satellite technologies are used in precision farming. This often occurs when drones take high quality images while satellites capture the bigger picture. Drones are being implemented in agriculture for crop health monitoring, irrigation equipment monitoring, weed identification, herd and wildlife monitoring, disaster management, mass data collection, land survey, seeds planting, using fertilizers, using pesticides and water irrigation, etc. Other technology is remote sensing and crop sensors. Remote sensing is directly connected with satellite. By the help of these techniques, finds out the monsoon, ozone layer depletion, smog, etc. The use of crop sensors can make it easy for farmers to effectively apply fertilizers and pesticides just as much as the crop needs. Then smartphone applications. Smartphone and tablet applications are becoming increasingly popular in precision agriculture. Smartphones come with many useful applications already installed, which are including the camera, microphone, GPS, and the accelerometer. There are also applications made dedicated to various agriculture applications such as field mapping, tracking animals, obtaining weather and crop informations, and more. They are easily portable, affordable, and have a high computing power. Now, use of GPS in field documentations. GPS is becoming a common technology in agriculture. The data about weather trend, demand of crops, land mapping, distribution channel, and market rates can help the farmer align his strategy for best result. Farmers can get quality insights on environmental factors and latest farming techniques through various tools. Other technology is Internet of Things for agriculture. The world of Internet of Things has so many innovative ways to offer to the agriculture industry. Farmers can improve their prospects significantly through Internet of Things for agriculture, like remote crop mapping, remote equipment management, weather forecast, livestock geofencing, warehousing, storage, and sensor-based resource management. In precision farming, some basic tools which are used are tractors, combines, sprayers, planters, and diggers. The small devices on the equipment that uses GIS, geographic information systems, are what makes precision agriculture what it is. To be able to use precision agriculture, the equipment needs to be wired with the right technology and data systems. Here to study the challenges in adopting precision farming in India. First one is lack of success stories. Precision farming is new story to Indian farmers need demonstrated impacts on yield, uncertainty on returns from investment, on new equipment and information management system. The adoption of precision farming in India is yet in the nascent stage due to its unique pattern of land holding, poor infrastructure, lack of farmers' inclination to take the risk, social and economic conditions, and demographic conditions. Second challenge is a small farm size. The small size of land holdings in most of the Indian agriculture limits economic gains from currently available precision farming technology. Third challenge is culture and perceptions of the users. Cultures, attitude, and perceptions of farming, including resistance to adoption of new technologies and lack of awareness of environmental problems. Other challenges, land ownership, infrastructure, and institutional constraints and market imperfections are not permitting significantly to move to the precision farming to those farmers. Heterogeneity of cropping systems. There is inadequate understanding of agronomic factors and their interactions. Lack of local technical expertise, knowledge and technical gaps. The complexity of tools and techniques requiring new skills, lack of understanding of the geostatistics necessary for displaying a spatial variability of crops and soils using current mapping software. There is high initial investment, which is working as a limiting factor to move to the precision farming. Data availability, quality and cost. High cost of obtaining site-specific data is there. Limited ability to integrate information from diverse sources with varying resolutions and intensities. So these are the factors which are working as a challenge to significantly improve the precision farming adoption in India. Now here we will go through steps to be taken for implementing precision farming in India. There is the need of creation of multidisciplinary unit involving scientists from various fields, engineers, economists to lay out design for precision farming. There is need for the formation of farmers cooperative which are especially trained and focusing for the precision farming adoption. Governmental legislation to use agriculture inputs judiciously, and there should be pilot study to be conducted on farmers field to show the results of precision farming, and need for the creating awareness amongst farmers. So these are the steps which are needed to promote precision farming. So this presentation was all about precision farming. Hope this will be useful to all of you. Thank you very much. I have given here my YouTube channel details, Journey with Vijay Kumar Shrivastav. Having a request, please visit the channel, subscribe it, and provide your kind and valuable feedback. Thank you.